Revit is a three-dimensional architectural software program that is part of the BIM category. BIM stands for Building Information Modeling, which means that the objects created in Revit have information associated with them that the user can then extract and show in many different forms. Let's take a look at an Autodesk video that explains more about BIM.
First, there was pencil and paper. Then came the lines, arcs, and circles of CAD, which transformed labor-intensive drafting into efficient electronic documentation. And then CAD went 3D. And now, it's all about BIM. What is BIM? BIM is an intelligent, model-based process for planning, designing, building, and managing buildings and infrastructure. BIM creates more than just digital 2D or 3D models. BIM models use objects that have intelligence, geometry, and data. If a model element is changed, BIM software coordinates the change in all views that display that element, because they are all views of the same underlying information. Architects, structural engineers, contractors can work more collaboratively, accessing and updating the design, and the information is captured in the model and remains consistent and coordinated. But what makes BIM really exciting is what you can do with all that information in the model. The power of BIM lies in the information. At any point in the life cycle of the project, the information is there, accurate to help reduce time-consuming errors and rework, accessible from virtually anywhere at any time by all the project stakeholders, and actionable to help inform your decision-making with simulation and analysis. BIM helps everyone working on a project to coordinate and communicate seamlessly. With all project team members working on the same building information model, knowledge transfer is streamlined. This leads to improved accuracy and reduced rework. BIM helps to convey design intent from the office to the field, reducing change orders and field coordination problems. BIM solutions from Autodesk form a comprehensive portfolio of tools that help you capture more value for every phase of your work.
Another aspect of Revit is that it is a three-dimensional program. That is, the user can model the building in 3 dimensions and produce images like these that you find on this sheet. However, it's not just pretty pictures. You can create from this 3D model 2-dimensional drawings like this floor plan, this roof plan, elevations, sections, and even details. Let's take a look how Revit does this. If we go to Revit, you can see that the main screen area is right here. This is where you will do your modeling. Right now, we're on a floor plan view, as you can see over here, level 1. If we were to build some walls, we're not just drawing some lines, even though it might look like that. It actually has a height and a thickness to these walls. We can look at that by clicking on this Default 3D View button. And if I shade the view, you can see it even better. But how does Revit go from this 3D model to a floor plan view? Let's take a look. Let's say we modeled this house in Revit. Well, Revit takes this model, this 3D view, and if you wanted to see an elevation, Revit defines the elevation as looking at from this point and looking directly at the front face, or whichever face. Similarly, if you're going to ask Revit to show you a floor plan view, Revit will take a cut through the building 4 feet above the level and look down from there. So it's actually using this 3D model, this 3D view, And it takes away, for a floor plan view, it'll actually take away all of these walls instantaneously and look down onto it, and that's how you get a floor plan view. Likewise, if you are asking Revit to show you a section view, a section is a cut through the building vertically, Revit will take this and cut the building like so. Where the red is, it'll cut that. Everything in front of the red here, Revit will erase so that you can then look inside the building from here, and that's a section view. As we work with Revit throughout the semester and we get more comfortable with it, one question that always comes up is, how much do you model? Well, I'll tell you the answer. The answer is it depends. Here's an example. If we go to the house example, let's pretend we've modeled this in Revit, and we've modeled the walls and the roof, and those are the big items, the big objects, so therefore we model them. But what about the more detailed items? What about a downspout? A downspout is the object that carries water. This is the downspout that carries water that's collected in the gutter down to the ground. So here's our gutter and here's our downspout. Well, do we model the downspout or not? It's just as easy to draw two lines on an elevation and call it a downspout, and it might even be easier to do that than actually model it. But why would we model it? A couple reasons would be, one, we want to see it in our three-dimensional views. If we draw it in 2 dimensions with just 2 lines, it won't show up in our three-dimensional views. If we really like downspouts and we really want to show them in our design and our presentation, then we might want to model it. If we're really good at modeling, then it's probably just as easy to model a downspout than it is to draw two-dimensional lines. Another reason would be if we wanted to schedule it. Going back to the idea of BIM, Building Information Modeling, if we actually model this downspout, we can assign information to it. We can say what material it is. By modeling it, Revit will know how long it is or what diameter it is. And therefore, it can calculate costs. It can schedule it. It can tell us how many of these we have around the building. All of these we cannot do if we just draw it with 2 lines on an elevation. Let's look at another example. If we're going to build a wall in Revit, what are we actually going to build? Well, in real life, we would build studs and put gypboard on the inside and maybe plywood and stucco on the outside. But do we really want to do that in Revit? Revit thinks of walls as planes with a thickness. And then we just assign the inner layer as the stud layer. So we can come in here, let's call this a stucco wall with gypboard on the inside. Well, we know the studs are going to be either 2x4s or 2x6 at 16 or 24 inches on center or whatever. We actually don't need to come in and draw them because that would take forever. Well, or do we want to? Well, you know the answer. It depends. What does it depend on? It depends if we want to schedule or know things about the studs. We could model all the studs and then show a contractor exactly how it's going to be built. But a contractor knows how to build a wall with studs. Do we really need to show it? If we model every stud, it might start slowing down our program because of all the memory it might take up. So really, in most cases, we're not going to show the studs. We're just going to show a layer of studs without actually drawing every stud. So we call this middle layer the stud layer, and we make it the right thickness. If it's 2x4, then this thickness is really 3.5 inches from here to here. And then Revit will want the other layers. So we have a stud layer here for a wall, and then we will come in and draw a chipboard layer. And we'll define the wall this way, and so we don't have to draw all these layers as we work our way through Revit. We just say, for this wall type, we want chipboard on the inside, like so. And now whenever we model this wall type in Revit, it'll come with a stud layer and a chipboard layer.